Why is thermal imaging data tricky for conduction analysis? Imagine trying to see inside a solid object just by looking at its surface. Thermal imaging gives us surface temperatures, but understanding how heat moves inside is a whole different story. When we use thermal cameras, they detect infrared radiation emitted from the surface. But this radiation depends heavily on the surface's properties, especially something called emissivity. Surfaces like shiny metals reflected infrared radiation from the environment, which can make the surface look cooler or warmer than it really is. This reflection can mislead us about the true temperature, making it tricky to analyze conduction accurately. Conduction is about heat flowing through the inside of a material, from hot to cold areas. But thermal imaging only shows us the temperature at the surface, not inside the object. So, if the surface temperature doesn't match the internal temperature, we might think conduction is happening differently than it actually is. For example, heat could be moving inside, but the surface might not have caught up yet. Or, surface temperature changes could be caused by other heat transfer methods like radiation or convection, not conduction. This makes it hard to tell what part of the heat transfer is really due to conduction just from a thermal image. Environmental factors also play a role. Things like ambient temperature, nearby objects reflecting infrared radiation, or dirt and coatings on the surface can all affect the thermal image. These factors add noise or errors, making it even more difficult to isolate the heat transfer happening inside the material. Plus, thermal cameras capture temperature at specific points or small areas called pixels. To understand conduction, you need to see how temperature changes across the entire surface, which is hard to do with just a few pixels. In real-world situations, thermal imaging is great for spotting hot spots or insulation problems on surfaces. But for analyzing conduction, it's not enough on its own. Usually, you need other tools like contact temperature sensors or computer models that consider the material's properties and environment. So, the main reasons thermal imaging data is tricky for conduction analysis are that it measures surface infrared radiation influenced by surface properties, reflections, and environmental factors, not the internal heat flow. Surface temperature might not match internal temperature gradients, and the data points are limited, making it hard to get a full picture of how heat moves inside. Knowing these limitations helps us understand why thermal imaging is a helpful tool but often needs to be combined with other methods for a complete conduction analysis.